do want to thank the IAFE for the excellent selection of topics for these competitions. I guess we should also thank them for the excellent selection of judges, since we've done so well these 2 years. But our team and our program operates on a slightly different academic schedule than most. So when this competition comes out, our students are on their internships. So they're not together at the time of the competition. Makes it a little more challenging and interesting. And our team of 6 folks is sort of our now new normal all-American Berkeley team. 2 are from China, 2 are from India, 1 is from Canada, and 1 is from the US, based on their undergraduate schools. And appropriately, the US undergraduate is Cornell University. So let's feel right at home here. The other aspect of the competition and the team is, since they were in their internships, 3 of them were in San Francisco and 3 were in New York. And so they had to coordinate across that. And we are, of course, very proud of the team and very proud of our program. And I'm going to turn this over to the captain of the team, who is from undergraduate in Renmin University in China, Alfred Yuan. Alfred.
Okay, so thank you, and I'm Alfred. So basically, at that time, all of the 6 members of our team are doing the internship, and then the IFA, I mean, as usual, released the notification of this competition, and then the members, the ANAP, contacted me and asked me to draft a team to participate, and then I called the other 4 members, and we formed a team. So and we actually. I do not think this is a very easy topic for a math level student, because it's quite macroeconomics, and we're used to the quantitative modeling in our program. So we spent like 3 weeks to figure out actually how to tackle this problem and how to make our solution reasonable. And then after 3 weeks, we figured out that maybe so we figured out that the systemic risk measure is a key factor of our paper, and then we start to do all the empirical tests and do all the modeling, and then write the paper. So I think why not then just introduce E directly to do the introduction and the literature review for our project.
Thanks, Alfred. So I'd just like to thank the other team members who couldn't be here, Arnab Chakrabarti, Shivesh Gupta, and Lisa Lee. And so just to talk a little bit of background about the project and our introduction. Maybe I'll stand away from the microphone. So looking at the financial crisis and sort of Basel III coming out of that, there are some lessons here which are the importance of systemic risk, as Alfred mentioned, the potentially inadequate equity capital requirements, the fact that liquidity matters. It's not just about risking loss of capital, and other sources of risk, procyclicality and counterparty risk. And in relation to that, also the fact that financial shocks can have spillovers to the real economy. And so this is the sort of backdrop that we're thinking about when we analyze Basel III. And this is a case study. So it asks us to do a portfolio maximization, first from the manager's point of view, so profit maximization, and then also look at that same maximization from a risk manager's point of view. What might they care about that perhaps the managers are not considering? And then finally, from a regulatory perspective, what do regulators care about that perhaps individual firms don't care about? And as the conclusion is that it's really about systemic risk from our point of view. The first run through is with fixed leverage, and then we have endogenous leverage. And finally, from the perspective of the financial crisis, again, you probably hear this a lot, is that the fact that you don't really care about systemic risk. It's more, you care about systemic risk, not rather individual risks. And so this is just a map of Basel III, and so we're going to be focusing on capital adequacy. And so the Basel III framework, for us, the primary goal of regulation is to prevent a systemic collapse. rather than to focus on the individual bank failure. And so we're going to look at the first two capital ratios, equity capital, and the leverage ratio as sort of binding constraints. Basel III also covers sort of liquidity ratios, but that's outside the scope of this project. And we thought about ways we could go slightly outside of Basel III. So one is when we're measuring portfolio risk, we're looking at the expected tail loss rather than just the VAR cutoff, so the actual weight of that tail. And then for measures of systemic risk, there are definitely a couple of, from the literature, we took two measures. One is COVAR, and the other is marginal expected shortfall. And these measure the sort of try to measure the contribution of a financial institution to systemic risk relative to sort of a median value. And my colleague, Alan, will talk more about the modeling setup. Here you go.
Okay, so here is basically how we tackle all the problems outlined by the problem set. So first of all, we constructed a very simplified world. So of course, bank's balance sheet has lots of holdings. You can consider it as a portfolio, which, well, here actually loans is, well, it's not only loans, but all kinds of assets. And the cash reserve is implicitly allowed because when you have, when the aggregate weight from this part is less than 1, you basically have cash holdings here. And we only allow 3 assets, 1 bank loans. Let's just say it's typical like generic bank loans, and 2 traded assets. So asset returns follows normal distribution. This is mentioned. So our focus is on capital adequacy. So in Basel III, it's proposed, 4 pillars are proposed. But really here, we don't go into liquidities or stable funding because the problem set is focused on capital adequacy. So we really will study the capital requirements. Because of the different treatment on trading book and banking book in Basel framework, we will further categorize banks into 2 types. One is broker-dealer. We let broker-dealer have only trading book with liquid market instruments. So basically, those 2 traded assets. So their capital charge will come from the VAR of their traded assets. It's called market risk capital charge. Well, there is a specific risk charge here, but we assume the counterparty risk is negligible, so consider it as an exchange-traded asset. So the SRC here is equal to 0. So we really will take the VAR to calculate the capital charge. For commercial banks, they have both a banking book and a trading book. Well, capital charge on banking books is taken as 8%. So we have a hard constraint on their business model. So at least 55% of the risk-weighted asset will come from the banking business. That's how we define commercial bank, basically. So we have 4 problems at hand. Well, that's basically the reason why we want to simplify things. So this graph basically shows you the feasible set, well, using simplified graphs. So, well, here, well, the way we are able to draw these graphs is we only assume there's 1 asset. So the risk weight will determine the basically the capital requirements set by Basel III, and under the fixed leverage scenario, we'll investigate low and high leverage. But in an endogenous leverage part, the feasible set becomes a shape here. So the first one, it's like a baseline model for us. It's to maximize profitability within Basel constraint. So the objective is to maximize the net return on capital. we have the capital constraint given by Basel requirement, and this general constraint is basically you have non-zero asset weights. And we would explore two scenarios, high leverage and low leverage. So the second part is from the perspective of risk managers. So we think the concern of risk managers is that the capital should not fall below regulated level when something happens. So to do that, we need to set aside a capital buffer, which should correspond to the expected loss in the asset holdings when extreme tail events happen. So that's why we take 99% of conditional VaR to calculate the additional capital charge that we need to hold. It's called economic capital in many places. So it's exactly the same thing. The optimization problem here basically becomes, essentially it's the same one as the last one, but with the modified capital constraint. So here, this is the additional economic capital that the internal risk management department will require. Okay, sorry. The third one is actually the focus in our study. So optimal portfolio for regulators. In the last two problems, we only studied the standalone risk for institutions. So the constraints are only focused on preventing the single institution from failing. However, like bank failures not always trigger a systematic event. And from a regulator's perspective, really, they care about a systematic failure. They care about the spillover effect from a single institution instead of like an isolated banking failure. So that's why we think the solution from the previous problems might be suboptimal for regulators. And the way to fix it is to introduce introduce a measure for systemic risk. So if we can measure the contribution of their asset holdings to systemic risk, we can basically improve the Basel framework. There are two candidates for measuring the contributions to systemic risk. From literature, we identified a marginal expected shortfall and the CoVaR. These two are basically another kind of conditional variate risk in a sense that it measures expected loss conditional on the broad market distress. So, however, in our simplified world, it basically breaks down to the correlation. So they are all proportional to correlation. So it doesn't really matter which one we pick in our framework. So, and another thing is that since the risk measure measures the conditional loss, we can actually derive a risk weight from that. So consider equaling the expected loss to the well, basically expected loss gives you a capital buffer, right? And the capital buffer can be think of as a risk weight. It's like the well, it's mentioned by the previous speaker actually. So basically we follow that approach. We derived a new risk weight from a systemic risk measure, and we substituted it. We basically replaced the older risk weight with the new ones, and we reduced the previous two problems to see if there's any difference. Finally, the case for endogenous leverage is, well, basically studies when banks can freely alter their capital structure without cost. So here we introduce a leverage constraint from Basel III, which is newly proposed. So here we have this constraint here. However, the other part is the same as before. Okay, so to implement this model, we need like additional assumptions. So for the trading books, we basically map these two assets to actual traded assets. So you can consider it as one equity asset and the other is a fixed income asset. So the returns volatility and correlation are all like designed to so that they are realistic. And because of the volatility and the correlation properties, we label them as high risk and low risk, just to make it easier to visualize. For banking book, we follow a paper by Paukut and Schmelz. It's a study from Europe. So they used these numerical values for returns on bank loans, cost of debt, and average risk weight. So with that, we can actually implement the simplified optimization model. Here are the other results. So there are several highlights from our results. Firstly, the baseline model with only Basel constraint are very sensitive to leverage, which can be totally expected. Secondly, when you have internal risk control, it unambiguously reduced profitability and reduced risk taking, I should say. So it matches with reality because, well, risk managers has contradicting objectives as opposed to a portfolio manager or like a front office revenue generating department. So actually it's shown in our results. Apart from that, the key observations is from Q3. So when we introduced the systematic risk weight, it did a good job in a sense that it penalized the banks with high risk, but doesn't change much for safer banks. Or in some cases, even allow the safer banks to take a bit more risk. So it actually did a perfect job in differentiating risky banks and safer banks. And also, the effect is not, it's somehow independent from leverage. So even you have high leverage and low leverage, the effect is still there. So it cannot be achieved simply by having a hard constraint on leverage. Of course, that's only from our simplified model. But in a whole, we think it makes perfect sense to us, and it shows how a systematic risk measure can work well within a Basel framework. We have one additional result for endogenous leverage. So here, because the capital structure is variable, introducing a systematic risk weight can force the banks to enhance their capital base. And in the case of commercial banks, it actually pushed them to be focused on traditional banking business. So their loan book will actually expand, while their trading book will take less risk. So, well, with other results, we think it makes sense, but from a practical perspective, we still need to make sure we have such a systemic risk measure, and we can determine it empirically. So that part, Alfred will introduce you how we test it empirically.
Okay, so after previous discussion, so it is quite natural for us to find a systemic risk measure in order to incorporate it into a regulatory framework. And as mentioned before, we mentioned two systemic risk measures. One is the CoVaR, and another one is the MES. And here in our paper, we implemented the CoVaR proposed by the Dr. Tobias Adrien and the Professor Bruno Meyer. And the CoVaR is the value at risk of financial system conditional on the institutions being under distress. So for here, I think the definition of value at risk should be quite straightforward for all members here. It means it is a threshold for a given portfolio or the institution or asset for a given period. I mean, it will be there. I mean, for the probability Q, the institution or the portfolio will not be under that threshold, and then here we go directly to the definition of the CoVAR. The CoVAR means that so the underlying is institution I, given a specific event of the institution I. So what's VAR of the institution J? And here we specify the J as a system in our paper. Also as the original paper. And then you can see it means given the specific event of the institution I. So what's the VAR of the financial system? And here we denote the delta CoVAR as the CoVAR at the confidential level Q minus it at the median level. So it means the marginal contribution from institution I to the whole financial system. So here it means we specify the J as a system, and we have the systemic risk measure. Okay, so actually the CoVAR can be calculated by this two-stage quantile regression, and one major difference between our solution and the original paper is that in the original paper, the AXT, it is defined as a market value of total assets. So basically, you have the market value of the equity, and then use a book-to-value ratio to adjust to the market value of total assets of each institution and the financial system. But for our paper, we use the weekly returns of institutions and the financial sectors directly. Frankly, because the time is limited, we did not incorporate the data in the compute set to calculate as the original paper. But the result is similar, it's quite similar. And the M here is one period lagged, the macro factors. So basically, for the two-stage quantile regression, so for the first stage, we treat the macro factors as a control variable and calculate the VR of the financial institution I. And then we make the VR of the financial institution I as a control variable together with M to calculate the CoVAR of I on the system. And then for the macro factors, we use the three sets of macro factors. The first should be the very common macro factors, the VIX, and also the short-term liquidity spread defined as the difference between the 3 months repo rate and the 3 months bill rate. Also, the third one is the change in the 3 months treasury bill rate. And the second set is the fixed income factors. Is the change in the slope of the yield curve and the change in the credit spread between BA-rated bonds and the treasury rate. The last set of macro factors are the equity market factors. So one is the weekly equity market return from CRSP and also the weekly real estate sector index return. So here, after estimating the parameters in the two-stage quantile regression, then we can calculate the delta CoVAR for each institution in the prediction manner. For the regression, and then so here is a plot for two institutions. We use the data from the December of the 1997 to the December of the 2010, and you can see for this part. For the internet bubble, the 2000, and also for the financial crisis from 2007 to 2009, the CoVAR is quite significant. It means the contribution of these institutions to the system is quite significant. And also, the next slide shows another two graphs. They are quite similar for the patterns. Okay, so because this competition asks us to discuss empirically. So, what would it be? For our proposed regulatory framework behave in the previous financial crisis and the 2011 euro crisis. So we calculate these two tables. So one is right prior to the 2008 financial crisis, and the second one is prior to the 2011 euro crisis. And so basically, we pick a random day. So how can we define random day? It means that actually, so it's like so it's between that period. It's under July 2008, and we found for most days of that month, the results are quite similar. And then we just pick one day out. And if you do that for other days, you can get a similar pattern and a similar rank. And the good result is that for the 2008, the Lehman Brothers cohort, the Delta cohort is the highest, and later declared bankruptcy. Okay, so and also we only did this for the top liquid 30 financial institutions. And if you are interested in this risk measure, you can go back to the original paper, and they did that for all the financial institutions. Because the key point here is that we think a systemic risk measure is important, but which risk measure you choose actually depends on your preference. Okay, so welcome Alan to do the conclusion.
Okay, so to conclude, we think the focus on standalone risk is potentially a shortcoming for existing Basel framework. So we are trying to, we think incorporating a systematic risk measure can potentially improve it. And in a simplistic world, we have shown that if you have a weight that is derived from a systemic risk measure, then you can achieve a better effect compared to existing framework. And to make it practical, we also shown that you can actually find a measure empirically that can have a decent forecasting power on the contribution to systematic risk at the institution level. So it makes it feasible to implement a regulatory framework based on a systemic risk measure. So that's our findings for the paper, and thank you very much. So we can take one question.
In the table that you put up there of where you have the single days before the crisis and before the euro crisis.
Yeah, we picked
this one here. What is there anything to be concluded from the fact that the measures on the right-hand side are higher than the ones on the left-hand side? Or bigger, I should say.
Yeah, it is. Actually, we did not think about this effect. I mean, so why it's much bigger for the right hand side. Yeah. But because for the original paper, it only has data only has a result for that part, and we benchmark to their paper, and they're similar. Yeah.
But we shouldn't conclude that SunTrust is twice as likely as Lehman to.
We cannot conclude that. It means that so it's like it means maybe the exposure of the SunTrust to the European is high, but it's a little it's not so reasonable. But maybe it can reveal something of the the inside investment of those financial institutions.
Or I think maybe potentially because in 2011 you already have a price history of the bank's equity price coming out of the 2008 crisis. So you can think that the historical volatility of those equity returns are on average higher than if you do the same study in 2008. So I think that can actually distort the result. So part of the the magnitude in 2011 might be related to the higher volatility, historical volatility. Yeah. Thank you very much.
Well, thank you and congratulations.